Hey guys, welcome back to a new video. Uh, so today we are going to discuss about how you can build an offline first application from a system design point of view. You can get a lot of system design content from a backend perspective on internet, but I guess there is a very shortage of mobile system design videos on internet. So let's go ahead. Before jumping into anything, let's first understand what is an offline first application. In simple terms, an offline first application is accessible even if there is no internet. So let's say a simple to-do application, but it will be an offline first. Okay, so even if there is no internet, still the user will be able to perform CRUD operations, and there will be no difference in user experience whatsoever. So let's first discuss the principles that we need to keep in mind uh, while building a offline first application. The first one is immediate feedback. So any changes made in the application, it should be reflected instantly to the user. So let's say if I create a to do, I will make the API call, but I will not wait for its result to come back, whether the result is success or a failure. I'll simply store it in my local database and show it to the user that your to-do is created. Second one is data integrity. So definitely there will be a lot of unsynced changes from our local database to the remote database, and we need to flag those unsynced changes in our local database so that whenever we are syncing to our remote database, we can identify our unsynced changes. This can prevent our data loss. The third one is definitely background sync. If we have a lot of unsynced data in our local database, so we need to have a mechanism so that our local database keeps on getting synced with our remote database to have a consistent data throughout all the platforms. So these are the principles that we need to follow while building such kind of applications. Since we are going to create a to-do application, so let's discuss the functionalities and assumptions that we are going to have for this application. So first one is the CRUD operation should be there. So if I am a user, so I should be able to create, read, update and delete a to-do. Second one, it should be offline first. That's the point of making this video. Third one is background syncing. So we have to come up with a mechanism that all the data is getting synced to the remote database without any data loss. And fourth one would be authentication. Definitely every user will have its own to do. We don't want to have a common to do list for all the users. So yeah. So all of these functionalities will be authenticated only. There will be no unauthenticated feature over here. So user will have to log in first before accessing the application. Assumptions, we have one assumption right now at the moment that on logout user data will be deleted. Since we have an option of login, so there will be an option of logout as well. I'm assuming that whenever user chooses to log out, user data will be deleted from local DB, not from the remote DB. Since we have defined our functionalities and our assumptions, let's go ahead with creating our high level designs. So first we are going to see how we can create a high level design based on our defined functionalities and requirements. Here we are going to discuss about how our implementation will be and how data will flow and what will be all the possible scenarios we can have in the application. So all of those we are going to see from a high level perspective over here. Then after defining our high level design, we will be going to create our low level design, in which we are going to define our classes, like which classes do we want to have, what kind of database do we want to have, and what kind of APIs do we need, what params and what request body do we need for our APIs. So those kind of things we will be discussing when we will be creating our LLD. But right now we are going to create a design from a high level perspective only. So first of all, let's see how our screens will look like. So first one is our home page, where there will be a list of to-dos, and there will be an option to create one to-do from this plus button. Either we tap on this button or we tap on any of our to do, it will open a screen too, on which if it's a new to do, then the title and description will be blank, and there will be option to create the to do. And if I have tapped on any of the existing to dos, and the title and description will get filled over here. Let's just create one. Let's just say this will be the title, and this will be the description. If it's an existing to do, then we will have the CTA as update, otherwise the CTA will be create only. And the third screen we have is our login screen. There will be a login button, and mainly login, for simplicity, login with Google only. We don't want to get into the mess of managing passwords and all, so we'll just use Google login over here. So navigation, we can have a deep link based navigation. So like screen 3 can be navigated via /login, screen 1 can be via /home, and if you want to go to screen 2, if we have tapped on a particular to do, we will pass that to do ID in the param, otherwise it will be null. If it's null, it is meant that we have to create a new to do, and if there is some to do ID, definitely we are going to fetch it from our local DB and show its detail based on our to do ID. So that's how our navigation will look like, pretty straightforward. Now comes this interesting part, data flow. So now we are going to see how data flow will look like. So data flow will be determined in various terms. There can be multiple scenarios in which there can be different implementation of data flow. So first scenario is our app launch. A user has launched the application, then we will check if user is logged in. We will navigate the user to screen 1, that is the home screen. Okay, and if user is not logged in, we will ask the user to log in, and we will navigate it to login screen. Second we have is our login. How login will work? So now user will tap on the login screen, then we will use a Google login service to get user details. Generally we get email, name, profile picture. So after getting the details from Google account, we will use those details to make an authentication API call from our own server, and it will check from our remote database whether user is existed or not. If not existed, it will create one, and if it is already there, return the user details. We'll get the details from our API response, then we'll simply store it in our local storage and navigate the user to screen 1. So you can see that whatever response we are getting from our database, we are storing it in our local storage. Okay, so local storage is going to play a major role in this whole application, because our whole application will be derived from local storage only. So we have to keep it updated at every point. Now user has landed on home screen. So next thing will be to fetch all to-dos. Now there will be two operations that needs to be done. First, we will start observing list of to-dos from our local database. It can be in the form of live data or flow, whatever you prefer. Okay, so that any changes made in our local database, it should be reflected on our home page. Okay, and we will make an API request to fetch all the to-dos from our remote database. Whatever to-dos we receive from the server, we will update the local storage with with all the to-dos, and this time we will make the sync flag is true. That is, this data whatever we are going to save in our local storage is in sync with the remote server. In LLD we are going to see how we can actually are going to maintain this sync flag over there, but for now we are calling it a sync flag only. And as soon as our data will be inserted in a local storage, it will be notified to our UI, because in the starting only we were observing on our local database. Okay, so this will be the flow that we are going to have to fetch all the to-dos and show it on our home screen. Even if we don't show it on our home screen, we have to fetch the to-dos to update our local database. Okay, next thing is any CRUD operation, not CRUD operation, in fact CRU operation. This data flow will not contain the delete operation, because we have to manage it separately. I'll tell you in the next step. So any create, read or update operation performs. So if a user has tapped on this plus icon, filled the title and description and tapped on this button, this will be a create operation. If a user has tapped any of the to do, then using to do ID, first there will be a read operation, and after doing any changes, if he clicks on this update button, it will be an update operation. So these are the three operations that I'm talking about right now. So if any of those operations occurs, okay, so we are going to update our to do in our local database with the sync flag as false, because right now we have made the changes only in our local database. It is not synced with our remote database till now. After that, we will make an API request to execute the same operation. So let's say if it was a create operation, we will create one entry in our local database and make the sync flag as false and navigate to the screen one. And just after that, we will make an API call in the background thread and execute the create request, in which I'll just pass the title description in the body, and either it will be successful or it will not be successful. If it's not, then we will not update the local database. So it will remain, the sync flag will remain as false as it is. Okay, it will not get updated. But if it's get updated, so in that case we will update the sync flag as true. It is now in sync with our remote database, and this failure can occur, either there is some API failure kind of thing and this sync flag will remain as false. Okay, so this is how any create, read and update operation will work. So next we are going to see the delete operation, how delete operation will take place. So why did I kept this delete operations separate? So in any of these operations, we are not removing any content from our local database. Here you can see, before making the API call, I'm updating my local database. So if I include delete operation as well, I'll have to remove from our local database as well, and after that I will have to make an API. I'm making the API call. So if in that case my API call gets failed, it will not be getting synced with my remote database, and I have also like removed it from my local database. So on remote it will be present, but in my local database user can see that it's deleted. So there will be a discrepancy of data. So that's why it will not fit in this particular data flow. So that's why I have kept it as a separate operation. So whenever user tries to delete an operation, we will make a delete API call first. If it's successful, then we will remove the to do from the local DB, and this will not be required, I guess. Yeah, if it's get removed, we will simply remove it from a local DB, and since we are already observing on our local database, our UI will get updated automatically. But if the API call gets failed, we will mark that particular to do for deletion as true. We will have to delete this to do later on when we will perform background syncing. Its sync flag will be turned as false, so that whenever we will try to sync unsynced changes, this can be come into consideration. And while showing anything on our UI, we will have to apply one more condition, that is marked for deletion should be false. So we will show only those to dos on the UI which are not marked for deletion. So this was the flow diagram for delete operation. Like till now we have updated our local database a number of times. Now it's time to see how we are going to manage syncing process. So this syncing process is very crucial. How we will be able to sync those unsynced changes, and this because we have a lot of unsynced items over here, that if API got failed over here, we have the sync as false. If API got failed over here, we have the sync as false, and we also have to delete this particular to do from the remote database. So we have to sync those changes to our remote server as well. To do this, we will see one more data flow diagram for our background syncing. Whenever we launch an application, we are going to register a work manager which can run twice a day or every 1 hour or 2 hour, like however you feel data consistency matters. First of all, it will filter out all the to-dos with sync as false. Then it will check if for all the to-dos which has is marked for deletion as true, it will start making delete request in defined batches. Why batches? Because there is a possibility that our database can grow enormously large and it can have thousands of rows in it. So in that case, if we try to send all of those data in one API request, it will make the API very heavy, and this will lead to more often API failures, and this is not a good approach. So that's why we will try it in a batch of 10, 20, 40 based on your feasibility. Let's say first you pick only 10 items that are marked for deletion. If those items are deleted, we will simply remove those items from our local DB, and if not, again, if it gets failed, we will not update our local DB. It will remain as it is, so it can be taken into consideration or in the next syncing process. The second part, we will take into consideration all those changes that are because of these create, read, update changes operations. So we will this time we will make a sync request. We will simply, whatever we have in our local database, we will simply have to replicate it in our remote DB. We don't have to delete or remove any items. If there is a new to do created, we will have to create a new item over there, or if there is an update in a to do, we will simply have to replace it with a new content. So it will simply a sync request. So this will be a delete request, and this will be, let's say, a patch request. And if this API call gets successful, we will update the sync flag as true for all those to dos. And if this API call gets failed, again we will not update our to dos. It will remain as it is. The sync flag will remain false, and this will be now taken into consideration in the next syncing process. Since we are talking about a simple to do application, so that's why we don't have a lot of cases over here, but definitely if you're going to build a much complex applications, these things can be broken down again into n number of diagrams. So for now, these data flow diagrams are sufficient to define our architecture of our application, because we only have limited operations. So definitely we have limited data flow diagrams, but this will increase if you have a number of features. Now since we have defined all of these data flow diagrams, now let's talk about the architecture. So we will be using MVM architecture. So there will be three layers, that is UI, domain, and data layer. The UI will ask the data layer to fetch some data, and I need some data, perform some operations on it. So this data layer will be making an API request to our remote server, but we are not going to serve this response directly to a UI. We are going to update our local DB with this received response from our server, and then our local DB data will be served to our UI. This domain layer primarily in this case can contain mappers or DTOs to it. We will simply map the models from our entities to app level models. It's a good thing to have a separate models for both of them, because it helps in maintaining separation of concern very easily. So it's a pretty straightforward MVVM architecture, and you can also see for our UI layer, even for our domain layer, the source of truth is our local database, not our remote database. So whatever data we have in our local database, we are driving our application from that only. We are making the API request, but we are using those response to only update our local database. We are not updating our UI based on our API response. So this is the fundamental architecture for building any offline first application, that you need to serve your application from local database always. For now, we have seen what kind of screens will be there, and how navigation will work, and various type of data flows that we think we are going to need in our application. So that we have seen now, based on all of this information, and as we call it, all of this high level design, we are going to see how we can create a low level design now, that is our LLD. Okay, so first of all, we will define our entities. Mostly we are going to have two entities only. One is our user and other is the to do. So user will have an ID, name, email, profile pic. So these three things, that is ID, name and email, we can get from Google login service. And this ID will be our, will be generated from our own server. If you can see in our login data flow, that we, after getting a data from the login service, we are making our own authentication API call to our servers. So this will be used to authenticate user, and this is all the data I guess we need right now at the moment. Next we will have a to do entity. This will simply have a ID, title, description. In this field, ability that is important, because mostly we are going to use our to dos in descending order of timestamp. And this is completed will be there. If it is true, it means we have done this to do, this to do has been completed. And if it is false, it means it's currently in pending state. One thing I forgot to add here, that is there will one more field that is marked for deletion. While showing to dos on UI, we need to make sure that it is not marked for deletion. So we will have only these two entities as of now. Now we will have various kind of API endpoints. So first of all, definitely we will have our authentication API. So it will be a post request. In the request body, we can send email, profile pic and name, and in response it will return ID, email, profile and name, and also a JWT token. Okay, so this one I have not added it over here, so you can also add it. So this token is important, or you can store it separately in your, let's say, okay, shared preferences, because this you are going to use this very often. Okay, so we are going to save this JWT token in your shared preferences, because this token will have your details as well, and we can also maintain session expiry and timeout kind of thing using tokens. And if you don't want to use token, then you will have to pass your user IDs or email every time in headers, every time you make a request. So token makes life a bit easier. Okay, so next we will have to dos API, and this will be a get request, and this will be a paginated API. So like I said, we can have enormous amount of to dos, so we can simply fetch by pages, so that our APIs remain light only. And in the headers we can pass our token, and in the response we will get our to do object similar to this one only. And this is synced, and marked for deletion will not be there. We will have to manually map it while we will see it later on in our repository class. And next one is get a particular to do using a to do ID. So this will also be a get request. In the headers we will pass token, and again we will get a here we were getting a list of to do object. Here we'll be getting a single to do object. And next one, if you want to create a to do, so this will be a post request. We can pass our to do object in the request body, and in the response we can simply get success or true or false. Next, with the same API endpoint, we will have a patch request to update our to do. If you want to update any to do to our backend service, so we can use this. And similarly, to delete a to do, we will be having this particular, we will be passing to do ID in the request body, and in response we can simply return success is true or false. And next, but very important API that will have, that is sync API. This will have two types. One will be having a patch in case of only create, read, update operations, where is marked for deletion will be false, and second will be a delete request where is marked for deletion is true. And we can pass our to do object whatever we want to sync it to the to our remote service. Okay, so these were the list of API endpoints that we need. Next, for our UI layer, we are going to have a main activity, certain composables like this: to do composable, home composable, to do detail composable. All of those composables will be placed in our UI layer. And for now, we can have only two kind of view models. One will be to do view model, which will be responsible for all of the to do related operations, and the second will be user view model, and this will be mainly responsible for user management, like whether to update user data or make authentication API and all. So these will be the two basic view models in our UI layer. Then our domain layer will have different models than our entities. So we have defined our entities over here, and similarly we will have some models in domain layer as well, and we will derive our UI layer from these models, not directly from entities. We will map these entity models to these domain models, and we will use these domain layer models to derive our UI. So in this to do domain model, you can see we don't have is sync or is mark for deletion, because if we have some items that are marked for deletion, we will not map it to our to do model only, so it will not be getting added to our UI list. Similarly, for user, we don't need created at, updated at, or those kind of attributes, so we have removed it from here. And also we can place our mappers in domain layer only. So mappers for to do entity to do model, and list of to do entities to list of to do models, or user entity to user models. So whatever mapping we need to have, we can add it over here. And next we can have repositories. So there will be two type of repositories. One will be present in our domain layer, and the other one will be in our data layer. So to maintain abstraction, we will only define the actions and responsibilities of the repositories over here, and we are going to define all of its implementation. So user repository will have authenticate user, where it will require email, name, and profile pic of the user. And for to do repository, we'll have multiple responsibilities, like get all to dos from local, fetch all to dos from remote, create to do, and this will require a to do model, update to do, get to do, delete to do. Everything will be defined over here, and implementation for these will be defined in our data layer repositories. And yeah, so let's say whenever we are trying to get to dos from local, we can simply return a live data or a flow from our local database, which will contain a list of to-dos. Then whenever we try to fetch all to-dos from remote, we will fetch to-dos and update it into our local database. Then create to do will first update our, whatever we decided over here. So create to do will update our local database first, then we'll make an API call, and if the API call gets success, it will update the local database, otherwise it will not. And so whatever we have seen it in our HLD diagram, we can implement them in our repository implementation classes. Okay. Next, in the data layer, we will be having a work manager. We can call it a sync manager, and it will only take into consideration to-dos which are not synced with the remote server. And as we discussed above, there will be two parts of sync manager. First will be those to-dos which are not synced and marked for deletion. For that, we will make a delete request to delete to-dos in bulk in batches. And second one will be unsynced to-dos which are not marked for deletion. For that, we'll be using a patch request to update to-dos on our server. This covers our data layer as well. And for dependency injection kind of thing, you can use Dagger Health Coin if you are working on a multi-platform kind of application. Definitely would go for Coin, because Health, I'm not sure Health is supported there or not, but if you are building specifically for Android only, then you can go for Health. So I guess this covers the LLD now. So our LLD is pretty much covered. Definitely there can be other things as well, but based on our current requirements and the current features that we need in our to-do application right now, this LLD and HLD is enough. And after discussing all those things, we are able to decide in what direction we are going to go. Like we know what kind of entities we need to have, APIs we want to have. Now we just have to implement all of those things in the application. Now with all this information, we can easily build a scalable and a robust application in which even if we want to add certain new features to it, we can easily do that without interfering too much to our architectural level. And I guess that's it for this video. If you have any concerns or doubts, you can put it down in the comments, or you can DM me on LinkedIn. I guess that's it for this video. Thank you so much. See you in the next one.